Hi, I'm Brian Freer, tutoring high school physics. Today's topic, work and power. So first up, work. Work is defined as force times distance parallel to the direction of motion. Or more conveniently, work equals force times distance times the cosine of theta, where theta is the angle between the direction of force and the direction of motion. So if it turns out the direction of force is parallel to the direction of motion, theta equals 180 degrees, and cosine of 180 degrees is 1, leaving us with this equation up top. So let's use these equations. First up, you have an object of 5 kilograms pulled along a distance of 5 meters at 5 meters per second squared. Yeah, I only use one number for this one. So we get work equals force times distance parallel. And you'll notice the distance is completely parallel to the direction of the force and the direction of motion. So we get a force of mass times acceleration, so mass of 5 kilograms times acceleration of 5 meters per second squared times a distance of 5 meters. So 5 kilograms times 5 meters per second squared is 25 newtons. And then we still have 5 meters. 25 times 5 is 125. And we have newton meters as a unit, also known as joules, represented by capital J. Use that unit when you're talking about work. Okay, but what if you have the same object being pulled along by a rope, angled at 60 degrees from the direction of motion, but with a force of 50 newtons? Well, now we'll have to use the other equation. Work equals force times distance times the cosine of theta, where theta is in fact 60 degrees this time. Force is already given to us, so no need to calculate that. 50 newtons times a distance of 5 meters times the cosine of theta. Well, 50 times 5 is simply 250, and we get 250 joules times the cosine of 60 degrees. Cosine of 60 is just 1/2, and we're left with 125 joules, and yes, I did that on purpose. Next up, power. Power is simply a rate of work. It's work divided by the amount of time it takes to do that work. So we could take either of these situations and set them over some time. Let's say 5 seconds. So power will equal work of 125 joules over 5 seconds. And so 125 over 5 is just 25 joules per second, or watts. Okay, to recap. Work equals force times distance parallel to the direction of motion, or more conveniently, work equals force times distance times cosine of theta, where theta is the angle between the direction of the force and the direction of motion. When calculating work, you'll be left with units of newtons times meters, also known as joules, represented by capital J. Power is a rate of work, or work divided by time. When calculating power, you'll be left with units of joules per second, or watts, represented by capital W. Alright, that's all for now. Again, I'm Brian Freer. See you next time.